Good day, ladies and gentlemen, personalities. This is Mkondes Makaba from Tembela Maths Club, a club that helps learners to understand mathematics. Ladies and gentlemen, personalities, today we are dealing with adding and subtracting fractions. So at the end of this short session, you should know how to add fractions. That is number one. Number two, how to subtract fractions. And then overallly, how to add and subtract fractions. Because, for example, if you look at this one, there's a fraction here, there is minus here, there is plus. Sometimes you need to add and plus all at the same time. So how do you go about doing that? Right. Sorry. All right. So we are going to do exactly that. Okay. Now, before we even get into a lot of nitty-gritties, there are some topics that are actually one topic that I think you should know before getting into this one. That is how to multiply a fraction with a fraction. That is very important because in this particular case, you will use that knowledge on how on how to multiply a fraction with a fraction in order to answer some of the questions. But it's simple things. So there is a video. You can go and look at them because it's very short, and then you can come and look at this one. But even if you don't want to look at this one, okay, we can continue. It's okay. But it's just that if you want the in-depth knowledge in terms of how that goes, or you are very confused in terms of how that goes, then I will highly recommend that you go and look at that video right in the same channel here at Tembela Maths Club. All right. Now, ladies and gentlemen, what is a fraction? Let's start off there. A fraction is, for example, it's a certain number. So let's say 2 over 3. Okay, it's a certain number that has two parts, and then this part is called the numerator, and then this part is called what? It's called the denominator. All right. This is the numerator, this is denominator. The numerator is just a fancy word for a top part. Denominator is just a fancy word for what? For a bottom part. Alright? Okay, so now if you've got these kind of things, how do you go about in adding and subtracting them? Let's take an example. Okay, here's the first example. Aha, there we go. Let's say you are told to evaluate 1 over 3 over plus 2 over 3. 1 over 3 plus 2 over 3. I want you to notice that the denominators are the same here. So because the denominators are the same, we are going to do the following. We're going to say equal to. We take one of these denominators to represent both of them, and then we'll have 3 here. And then we take this one plus 2 as it is. So 1 plus 2. Okay. And then we end up having what? We end up having 1 plus 2 is 3. And then you bring this 3 as it is. And then what is 3 over 3? What is 3 divided by 3? 3 divided by 3 is 1. So our answer is 1. Right. Now, you can go ahead to your calculator just to check if we did not make any mistake. You can put this exactly as it is. You will come out with this kind of thing. All right. So the denominators are the same here. Okay. Right. Okay. Let's take a second one. And number 2. You've got 1 over 2 plus 3 over 2. All right. You are also supposed to evaluate it. Guys, evaluate is just a fancy word for saying calculate. Okay. So don't be confused around it because terminology sometimes confuses a lot. All right. So here you can see denominators are the same in the same way as it was here. So things are nice if that is the case, ladies and gentlemen, personalities, because you will take 2 to represent both of them, and then you take this exactly as it is. 1 plus 3, which is equal to, this is 4 over 2. 4 over 2 is equal to 2. All right. So in both these cases, denominators are the same. So when denominators are the same, you just take one of the terms and then it represents both of them, and then you take the upper part literally exactly as it is. Don't change anything, you take it just as it is, and then you start calculating, and then you find your answers. Okay, so from this, it then turns out to us that basically if we have A over C plus, sorry, if you have A over C plus B over C, this is the same as what? As A plus B over C. So this is equal to this, and at the same time this is equal to this. Okay, so if you see this, you can represent it as this. Okay, so if you see this, you can replace it with this, or if you see this, you can replace it with it, depending on what you want to do at that particular point in time. Okay, that is why, for example, if you've got, let's say you've got x minus 1 over 2, this is same as what? As x over 2 minus 1 over 2. Okay, because this denominator was shared amongst these terms. So because of that, you use this rule to say, okay, now this must divide this one, and then this must divide this one. So you come up with something like this one. All right. Okay, this was just a snap that I was just giving you. You will use this a lot in the future. Okay, but for now, let's continue. Okay, let us take another one. Okay, now let's take 1. This is number 3. Let's take 1 over 3 minus 7 over 3 plus 2 over 3. Guys, now there's 1 fraction, 2 fraction, 3 fraction. There are 3 fractions and there are more than 2. Guys, it does not matter. It doesn't matter how many fractions there are, as long as you've got denominators being the same. Aha, you do the same thing that you did in other fractions. So what is that? That is to open a big division sign and then put 3 in the middle, because it represents both the 3 of them, and then take these things as it is. It's 1, so it's 1. It's minus 7 plus, and then plus 2, and then 2. Okay, so 1 minus 7 is minus 6, and then minus 6 plus 2 is minus what? Minus 4, and then divided by 3. Now this is our final answer. Okay, right, wonderful. Now denominators are the same, things are nice, things are wonderful. Okay, now let's take another doubt. Okay, let's keep this here just for reference sake. All right, let's say now we've got something else. Let's say we're supposed to evaluate now this one. Okay, this one is, what is it? It's 1 over 3. 1 over 3 plus 1 over 6. Okay, this was number 4. 1 over 3 plus 1 over 6. Now what do in this particular case? we can see that denominators are not the same. The denominator here is 3, the denominator is 6. So they are not the same, because here denominators were the same. So our life was very easy here. Guys, when life is not easy, we'll always like to go back to a state where our life was easy and enjoyable. So we saw that when denominators are the same, things are nice. So let's try here and see if we cannot move this thing to a state where the denominators are going to be the same, so that our life can continue to be easy. Now, how do you go about and do that? All right, so these are denominators. So you need to find the lowest common denominator. Now, what is the lowest common denominator? It's lowest common denominator. Denominator. They call it LCD. Other people call it least common denominator. It's the same thing. Okay, mostly in America and stuff. In South Africa, we usually use lowest common denominator. All right, but it's all the same thing. Okay, let me just put least here, just in case there are some of you who are from that system, the American system. Okay, least common denominator, but it's all ends up being an LCD. Right, now, how do we then find the lowest common denominator? You must take the denominators as they are. So you've got what? Here you've got 3 and what? And 6. Okay, so what you must do, you must multiply these denominators until you find a same number amongst them. Okay, so for example, 1 times these things, you will get 6 and 3 and 6. Okay, and say now you say 2 times this thing, what are you going to get? 2 times 3 is going to be what? It's going to be 6, and then 2 times 6 is going to be what? Is going to be 12. There we go, ladies and gentlemen. You've got a common number between the table of 3 and the table of 6. So that means your LCD here, your LCD is equal to what? Is equal to 6. That means you must change your denominators, all of them, to be 6. This one is already 6. So there's no need of changing it to 6. Okay, but this one is not 6. So how to change it into 6? You go back here and then you say to yourself, okay, now in the table of 3, how did I make this number to become 6? I multiplied by 2. Okay, you multiplied by 2. Now, so I multiplied 3 with 2 to get 6. So because of that, what I'm going to do is I'm going to take my 1 over 3, né? And then I need to multiply by 6. Sorry, not by 6. I multiply by 2 so that I can get what? So that I can get 6. Okay, but ladies and gentlemen, if I do this, I'm changing the number. I don't want to change the number. Okay, so that I won't change the number, when I multiply by 2 here, because I want this 6, I must also multiply by 2 on top. Okay, so 1 times 2, I will then get 2, and then 3 times 2, I will then get 6. All right, so this is exactly the same as this, but it's just that now I have expressed it in such a way that the denominator is what now? Is 6. Okay, That is called rationalizing the denominator. Guys, I know you look very confused now. No problem. But when we do more examples, you will see how easy this thing is. Okay, so we then say, okay, we then take the 6 to here, and then we can say 6, or let's just do it here just to show. So we've got 1 over 3 times 2 over 2. Okay, this times 2, and then all of it plus 1 over 6, and then this times this is 2, and then this times this is 6, and then plus 1 over 6. This is equal to, and then you've got 6, and then there's 2 plus 1. Now 2 plus 1 is what? This is equal to 3 over 6. Okay, and then that gives you 1 over 2. Right? All right. Wonderful. Wonderful. All right, ladies and gentlemen, let's pick another one. Number 4. Let's say now we've got 1 over 2 plus 2 over 3. So how do we go about with this one? Here, the same thing as earlier. The denominators are not the same. So what do? You need to find an LCD. Okay, so how to find an LCD? You know what to do. You will say 2, and then you will say 3, and then times 1, then you'll get 2 and 3 times 2, you will then get what? 2 times 2 is 4, and then 2 times 3 is 6. Okay, and then times, okay, at the moment we haven't got a common number, so you will multiply by 3. Okay, so 3 times 2 is what? Is 6, and then 3 times 3 is 9. So there we go. You've got an LCD. So LCD is equal to 6. Okay, so now you must make both denominators to be equal to 6. You remember earlier you had to make only one, but now you must make both. So how do you do that? Okay, so you've got 1 over 2. Okay, how do I make 2 to be equal to 6? I must multiply by 3. Okay, I must multiply by 3 because here to get 6 I multiplied by 3. So what I'm going to do is I'm going to say times 2, and then because I did this here I must do it at the top as well, times 2, sorry, not 2, 3, and then 3, and then plus, and then I've got 2 over 3. Now how do I make this to be 6? I multiply it by 2, so times 2, but because I must do it on top as well so that the number won't change, I will then say times 2 as well. So what do I end up with? I end up with 1 times 3 is 3, and then 2 times 3 is 6, and then plus 2 times 2 is 4, and then 3 times 2 is 6. Okay, so now the denominators are the same, so life is so easy. So 6, and then I take the above as it is 3 plus 4, and this gives me nothing other than what? 7 over 6, and my answer is done. Right, I just had to find what? I just had to find an LCD. Now let's say We've got number 6 that we are supposed to evaluate. Now this one is 1 over 3 plus 5 over 2 plus 3 over 4. So how do I solve this one? Okay. Denominators are not the same. Now there are 3 fractions, but denominators are still not the same. Alright, they are not the same. So what do I do? Because the denominators are not the same, I find LCD. LCD is equal to, I do not know, so I'm going to say I've got this 3, I've got 2, I've got 4. I'm going to keep on multiplying this number with 1, 2, up until I get a number that is the same amongst these 3. Okay, so how do I do that? Okay, when I times this by 1, then I get exactly this. Okay, when I times it by 2, when I times this thing by 2, 2 times 3, what do I get? I get 6. 2 times 2, I get 4. 2 times 4, I get what? I get 8. I haven't got anything that are the same. Okay, these 2 are the same, but now here I haven't got anything. Okay, so let me continue. Now let's say times 3 now. Okay, 3 times 3 is 9, and then 3 times 2 is 6, and then 3 times 4 is what? 3 times 4 is 12. Okay, I do get these 2 being the same, but I haven't got a third one. Okay, so I can't do anything. I must keep on multiplying. Multiply by 4 now. 3 times 4 is what? Is 12, and then so 4 times 3 is 12, and then 4 times 2. 4 times 2 is what? Is 8, and then 4 times 4 is what? Is 16. Okay, I also haven't got the same number amongst this, so I must just keep on multiplying. Multiply by 5 now. 5 times 3 is 15. 5 times 2 is what? Is 10. And then 5 times 4 is 20. Again, I haven't found anything. Okay, now times 6. 6 times 3 is what? Is 18. 6 times 2 is what? 6 times 2 is 12. And then 6 times 4 is 24. Guys, can you see something? There's something interesting here. I have got 12 here. I have got 12 here. I have got 12 here. So our LCD is equal to what? Is equal to 12. So the point I'm trying to make here is that sometimes it's easy to find an LCD, sometimes it's not easy. The only thing that you must do is just to find the table of these 3 things, of this number, table of this number, and the table of this number. Okay, and then immediately when you find a number that is not the same, a number that is the same, then you know that that number is an LCD. That number, if it's the same across board, then that number is an LCD. Okay, so now how do I turn 12 and make it? How did I turn 3 into 12? I multiplied by 4. Okay, so because of that, I will then say 1 over 3, and I will say times 4, and then divided by times 4. Okay. And then plus 5 over 2. Okay, here, how did I make 2 to be 12? I multiply by 6. Okay, so now I would say times 6 over, and then times 6 as well. And how did I make 4 to be 12? I multiply by 3. So say 3 over 4 times 3, and then times 3. Then so what do I get? 1 times 4 is 4. 3 times 4 is 12. Plus 5 times 6 is 30. And then 2 times 6 is 12. And then plus 3 times 3 is 9. And then 4 times 3 is 12. So now I get 12 because the denominators are the same now. I'm exactly where I want to be. And then we take this thing as it is. So it's going to be 4 plus 30 plus 9. 4 plus 30. That is going to give me 34. And then 34 plus 9 is going to be give me 43. So it's going to be 43 over what? Over 12. Okay. And then that's it. And then let me take the last one now. Okay. The last one is number 7. It's 1.5 plus 1 over 5. 1.5 plus 1 over 5. So the question is, how do I add these fractions? Guys, we've got now a new kind of a fraction that we haven't dealt with before. This is called improper fraction. Improper fraction. Okay, so whenever we've got improper fractions, ladies and gentlemen, personalities, the only thing that we need to do is to turn these improper fractions into a normal fraction, a fraction that we usually get, that we are used to. Okay, so how do we then do that? Okay, so what we then do is we always take this number and we divide by it here, and then make it 2 like this. Okay, and then we'll then say 2 times 1, which is 2, plus this one. Okay, so you multiply this number and then you add this number. So for example, if you have a and then there is b over c here, so this will be same as, you will just take c as it is here, and then here on top you will say c times a, and then you'll get an answer, and then whatever answer that you get, you'll say plus b. So that is why here you say 2 times 1, which is 2, and then plus 1, which is 3. And then just to verify things, ladies and gentlemen, personalities, you can go to your calculator and put this number literally exactly as it is and say equal sign. You will see, you will come up with something like this. Okay, so this is an easier version of this one. And then you say plus 1 over 5. We've got these things again. Okay, we've got these things again. And then we need to find what? We need to find the LCD. Let's find the LCD on the side. LCD equal to, let's see. Let's put these numbers down, 2 and 5. So times 1, you would get 2 and 5. Times 2, 2 times 2 is 4. And then 2 times 5 is 10. Okay. Times 3 3 times 2 is 6, and then 3 times 5 is 15. All right, and then times 4. 4 times 2 is 8, and then 4 times 5 is 20, and then times 5, because we haven't found anything, which is the same, times 5, and then 5 times 2 is 10, and then 5 times 5 is 25. Eventually, guys, we have found numbers that are same, is 10 and 10. Okay, now let's start with the first 10, the one that goes with 2 here. Okay, equal to 3 over 2. How did we make 2 to be 10? We multiplied it by 5. So because of that, we're going to say multiply by 5, and then multiply by 5, and then say plus. How did we make 5 to be 10? We multiplied by 2. So because of that, we'll then say 1 over 5 multiply by 2 multiply by 2, and then we'll end up with 3 times 5 is 15, 2 times 5 is 10, plus, and then 1 times 2 is 2, and 2 times, sorry, this is 5, and then 5 times 2 is 10. Aha, denominators are the same, we are sorted. So equal to, this is 10, this is 15 plus 2. So my final answer is what? My final answer is 17 over 10, and that is it. All right, so this thing that you are doing here, what is it called? It's called rationalizing the denominator. Okay, so when somebody says rationalize the denominator, they simply says that you must multiply that fraction with 2 things such that the denominator becomes a certain number that you are targeting at that particular point in time. So ladies and gentlemen, personalities, this is how to deal with fractions. This is how to add and subtract fractions. Guys, this is a lot, I know, but you can start this video afresh, start it slowly. Fractions are very confusing when you're doing them for the first time, but immediately when you get used to them, they become piece of cake. And as I said the other time, fractions, sometimes we can run away from them. It's always a good thing, or a safest way to run away from them when you see them. But at times you do get to a point where you can't run further. So when you can't run further, what must you do? There's nothing that you can do. You have to deal with those kind of things as they are. All right, so you must know how to do it. So this is how you add, and this is how you subtract fractions with fractions. All right, and then let me just do the last one. There's this last one that I think I should do. It's very important. Let me just do it on a new page so that you can see it. Let's say now we've got 1 plus 1 over 2, and call this one 8. How do you then solve this one? Guys, this is a number, this is a fraction. You know, when you've got fractions, you rather have everything to be a fraction so that your life will be easy. So what are you going to do? You're going to recognize that this is same as 1 over 1 plus 1 over 2. Now you've got a fraction here, you've got a fraction here. Sorted. Okay, now these denominators are the same. So you're going to find an LCD, you have 1 and 2. So when you times 1, you get exactly this. When you times 2, then 2 times 1 is what? Is 2, and then 2 times 2 is 4. Aha, so you get this and this being a common number. Okay, so now let's go to the one that says 1. So 1 over 1. How did you get 1 to be 2? You multiplied by 2. So you say times 2, and then times 2 here as well. Plus, this one is already 2, so there's no need. So 1 over 2. So you end up with what? You end up with 1 times 2 is 2, and then 1 times 2 is 2, plus 1 over 2. Okay, our denominators are the same now. And then what do we then do? You then say, okay, so this is 2, and then 2 plus 1. So what is 2 plus 1? Is 3 over 2. And that is it. You can put this exactly as it is on your calculator and you definitely get 3 over 2. This is how you deal with this thing. So whenever there is a number and fractions, just make sure that you make everything to be fractions so that your life will be easy. So ladies and gentlemen, personalities, thank you very much for tuning in and have a lovely day and goodbye.